5 o'clock, so I might start. I've got lots to get through. My name's Tarrant from SBS. Also here today I've got Ari Cohen, who's been a fundamental part of, put your hand up, who's been a fundamental part of a lot of this work as well. So if I don't get through everything, he'll be available too at the end for lots of questions. So a bit of a background on SBS, mostly for the international comers. We're a special broadcasting service for Australia. We're a TV and radio station predominantly. We offer multicultural and multilingual content for Australians, or not just Australians, but anyone in Australia. We are government funded. About 70% of our money comes from the government, and we're driven by a charter because of that. So we have specific things that we need to meet for all of Australia. We are also a commercial station. That's where our other 30% of money comes from. SBS has a huge online presence. It's relatively new. It's been around for 5 years, the online department, that is, and it's had a lot of rapid growth in the last 5 years. So we offer now, over the 5 years, a wide range of websites and applications. You can get iPhone apps for our news service. We've got on-demand TV available on pretty much all the mainstream devices, set-top boxes, you name it. We were the first to Windows 8 for a catch-up service as well in Australia. And just clicking through, these are just a couple of our main websites, like our cycling, our world news. Pretty much anything that's under the sbs.com.au banner is our sites. We have, I would say, maybe 10 main websites, but up to 60 other sites that are related to TV shows that we air. What runs our sites at the moment? Well, it's actually not Drupal. We have a bespoke CMS written in Zend. It's very hard and messy to maintain. Takes a long time to make changes, especially when they're network-wide. Let's say Facebook changes how they implement their share widget. If we were to actually change that on all of our websites, it would take a long, long time. We also have no consistent look and feel over our current network. So the decision was made that SBS needed a new platform, and Drupal was chosen. So, as I said, where's Drupal? Nowhere. So our goals that we've set for us is that we want an easy to maintain and extend our sites, especially from a developer point of view. We also want a better user and editor experience. Our editorial experience in our current system is rubbish. Even editing a basic node is a better experience than our current one. Our users, the workflow through our websites isn't as good as it could be as well. We also want to be able to repurpose our content across all of the network of our websites. As I said, we've got a lot of websites, predominantly news articles, and these news articles can appear in many locations across our network. Currently, it's virtually copying and pasting and re-uploading images. It's not ideal. We also want a goal, as one of our goals, is new ways to explore the content, and we need rich metadata to back that up. Exploring the content not only from a user perspective, but from internal in the office as well, editorial. They want to be able to find content really quickly if they need to repurpose it in, let's say, the news desk or something. We also wanted sites that are multi-device compatible, and along with all this, use more open standards. And most of all, a system that ends up being modular and decoupled, unlike our current system. And again, Drupal screamed all of this. But I'm not really here to talk about Drupal so much and why SBS has switched to Drupal. It's more about the back end behind what our Drupal sites will be running. So knowing that we have hundreds of thousands of articles, we were trying to think, well, does this fit in one Drupal site, or is it in many Drupal sites? Do we have one site that serves out all of it? Basically, we said, no, we're not going to have one Drupal site. It's too big of a site. It's too much risk. It's not decoupled, and that's one of our goals. Drupal multi-site, yes, it is using Drupal multi-site, but again, raises the question of how do we share this content between all these sites? So we've ended up using Drupal multi-site installs. We've got a base installation profile that runs across it. A lot of our components are the same across all of our websites or our new Drupal websites, common modules, editing interfaces, even a common theme that all of our new Drupal sites will be using, and then each each site, subsection of our sbs.com.au domain will have a extended theme with slight variations on the design. There's been a lot of work around the UX and D for the new platform. We did evaluate some of the existing multi-site stuff out there. So I looked at things like deploy, the deploy module, and just how it goes around pushing around content. There are a few others that can do shared domain kind of stuff. Basically, none of them could do what we actually want when it comes to sharing content around the network. So we had to put our thinking caps on and come up with a method that can actually work for us. And we discovered that we need two parts to the solution. And it's not just Drupal, but we needed Drupal as the website-based platform, but we also needed a common content repository. So we went through the motions of finding out what is involved with a content repository. And we found this great picture, which is pretty much every content repository out there and all the different standards. So you've got things like JCR, you've got CMIS, you've got PHP-CR, which is the PHP version of JCR. You've got things like Midgard, which are more C module-based for PHP. We could have used Drupal as the content repository as well. And then you've got all these expensive proprietary products as well. There were many to choose from. So we had to come up with a list of, how do we differentiate between them? What do we need exactly from our content repository? Because they all offer something slightly different. So I'll just step through this list that we more or less came up with. And we started looking at things of like, what does our content actually look like? It's, how is it being stored? What kind of content do we have? Well, we've got articles, but we've also got a food portal, which has things like recipes and restaurant data. So that's not as straightforward then. We've got scoring data on some of our other sports websites. We've had to really think about how we can store this and repurpose it on other websites. Then we looked at things like, well, how does this actually get stored behind the scenes? Does it sit in a MySQL database? Does it sit, and that takes me on to the next point of, is it in MySQL? Is it Tomcat running JCR? What kind of architecture sits behind this content repository? A lot of these solutions, there'll be an application, but then there'll just be this plethora of hardware and software that you've got to have behind it to actually be able to support it. And it just seemed overwhelming and really shouldn't have been that hard when we really started looking down that path. Then we had other questions of like, well, what content types exactly need to be stored and how is it going to shape them? Things like Alfresco kind of, they can store content in them. Admittedly, they're better for documents like Word docs, but they can store articles, but Alfresco is not really good for other kinds of content, in my opinion. Things like image storage. A lot of these content repositories don't store things like file assets that well. So that's any file storage. And the next question is, how do I search this repository with all my content in it? We didn't want to just put it somewhere and struggle to get it out, have to build our own crazy search on top of using an off-the-shelf product. So what ended up happening, not up to that yet. What about the communication layer? So a lot of those other applications out there, they've got varying standards of how they communicate with each other. CMIS is a commonly known one. JCR has its own implementation. They all use some form of XML or JSON or PHP modules, and they're all slightly different, and they all vary from being very simple to very, very complex. The specs for some of them, you could sit down and read for a long, long time, especially when you start delving into version control and wanting to implement that over an API service. So it was, again, all very, very complex and probably too complex for what we really wanted to achieve in a shorter time frame. So we went down the custom path, and there's many good reasons why. We aren't a Java house, so we didn't choose JCR. That one seemed pretty straightforward. We're a PHP house. PHP-CR, too heavy. The standards of how it stores all of its contents are very complex. It uses things like MySQL, and it actually ends up storing most of its content in a key pair format in the database anyway, so that raises scalability issues and all sorts of things. Alfresco is not really for a real website. Midgard 2 had some good ideas in theory, but if we wanted to extend it, it was potentially going to give us problems as well because it's more of a C application. Drupal itself was a good choice that we looked at. Open Publish extension itself had a lot of features that we really liked, but at the end of the day, Drupal won out more on the front end rather than the content storage. Drupal, especially Drupal 7, would have not been up to speed in performance and its API services to do what we needed to do around our content repository. So then we came up with a plan of exactly how we wanted our systems to interact with each other. And what we have is a whole bunch of websites sitting at the top of our stack. Drupal serves each of these websites, individual Drupal installs. It then has an API that can interact through a messaging service or directly with the client, with the content repository, and there's Apache Solr indexes in there to assist with searching the repository. So now I'm going to go through many of these components, the client API, the Drupal integration, the messaging service, and the exact schema that we ended up using in our repository and what software we use to build our repository. So our content repository itself, we built out in Symfony 2, of all things. Even though predominantly SBS has been working with Zend, we've chosen Symfony 2 for the content repository and moving forwards. It is well supported, as we know, has great coding standards, it's fast, has Doctrine, Doctrine's awesome, and we have existing Symfony 2 skills in-house anyway, so we're really just upskilling towards moving to Drupal 8, looking ahead. So that was our base framework. We then looked at things like how are we going to interact with Mongo. We chose to use Mongo over MySQL, mostly because of how the data gets stored, and I'll touch on that a little bit more soon. But interacting with the database is always a big part of the content repository and how you're going to go about doing it. As I said, Doctrine is awesome. They also have a MongoDB. So they've got a MySQL ORM, but they've got a MongoDB ODM, which fits perfectly. We have documents, we have articles, articles are documents, a document could go into our repository. It just all seemed to make sense at this point. We did, however, start out without using Doctrine. We were using Mongo and Symfony, but we wrote our own methods of interacting with Mongo. And what we found was we're trying to approach it from a schemaless point of view that, you know, it's really cool. You can get a JSON data, you can decode it, and you can just shove it straight into Mongo. And that's how easy Mongo is to do. We prototyped that in about 30 minutes. But when it actually comes to dealing with things like validation and making sure, you know, your content stays good quality for many years, you've got to actually still have some validation and abstraction there. And if Mongo goes away in a couple of years, you know, maybe it just, I don't know, another product comes on the market that's even better than Mongo, we still needed the abstraction to shift away from Mongo to another system. So that's one of the main reasons why we've ended up using Doctrine MongoDB rather than just direct access to Mongo. Why Mongo and not MySQL? It is very easy to use. If anyone has played with Mongo, you'll understand what I'm on about. And if you don't, play with MongoDB. It's fantastic. You can run it up easily on a VM. It's very fast to use. I've been shown a chart at the MongoDB conference where they were comparing MySQL and Memcache. MySQL is super slow, Memcache is super fast, and MongoDB is much closer to the Memcache end in terms of speed because it stores everything in memory and then slowly commits it to a file system as it needs to. It's a very memory-hungry application, but it is very, very fast. Replication in MongoDB is amazing. You can do it all on command line within Mongo's shell, and within about 5 minutes you can have 10, 20 slaves, and well, they're not really slaves in Mongo, they're primaries and secondaries, and they can hand over to each other very quickly and very easily. Replication in MySQL is a pain in the ass. We have many, many content types, and this was another reason why we chose MongoDB. And we know they look like articles. We know we're going to end up with an XML or a JSON API, and we really thought about how the conversion process from whatever it ended up in Drupal and the translation all the way through to how it gets stored in our content repository. And MongoDB seemed to simplify this process because it is BSON, which is just like JSON. So it just seemed to make more sense of how we stored the data. We wanted to keep things simple, and that's, again, the emphasis around this whole repository is keeping things simple. Many of our content types have a lot of fields. We have recipe and restaurant content types that we ingest from third parties. Our think our recipe content type maybe has 30 or 40 fields in our legacy system, maybe even 50 fields. It's a lot of data, not just things like addresses, but opening times, costs of different like entree, appetizers, you know, mains, desserts. There's just so much little data that we actually do need to show to the user on the front end. And we weren't quite sure how we should have stored all this data. So we ended up looking towards open standards of how we should represent this data. And we took schema.org as a strong guide here. Not only for the base, actually show of hands of who knows about schema.org. Okay, that's good to see. Looking on it, it answered a lot of questions really quickly up front for us. You know, are we going to call our content type an article? Yes, we are. We're going to call it a recipe? Yes, we are. We're not going to call it something crazy like SBS article. We're going to try and stick with something out of the box. But then we took it a little bit further and looked at all the fields on it and thought, well, they're field names already. They've been defined for us. Why not call a lot of our fields from schema.org as well? It makes the naming conventions much, much easier through all of our products and less developer mess in the long run. Having said that, though, fields in schema.org are limited. I know on the recipe content type, the ingredients field is just one massive text field. That's how Google loves it. They just look at that field and they work out what all the ingredients are. That's actually not how ingredients are stored in a content repository generally. You'll probably use taxonomy terms for an ingredient, or you'll have extra meta with it of quantities, and you'll store them all separately in different fields. So it didn't answer all the questions of field storage, but it really did help a long way in how we can standardize across different applications of how we call things. We also used Freebase as a source and a guide. We've actually ingested a number of taxonomy terms from Freebase to enhance our system and make it a lot richer. We've also used OpenCalais. We've passed every single news article that SBS has ever had online through OpenCalais, and now we have a massive vocabulary of everything that will make our content really, really cool soon. But we also have SBS-specific content types that, even though I mentioned recipes, we have some other ones as well. We have an electronic program guide that has a lot of custom fields in it that come from our TV scheduling software that runs at SBS. So again, schema.org wasn't the answer for everything, but it's been a good guide to helping us shape out a nice, strong system. So they're just some of the content types that SBS use across all of our network. It's nice, common types. So the next question that came up or needed to answer was, we've got Drupal, we know that. That'll be running all of our sites. We've got Symfony 2 and MongoDB in our content repository. But what's in the middle? As I mentioned before, there's a lot of standards on how you can communicate with a content repository. And CMIS was a big one that was open, and we really did look into it thinking, oh, maybe we really should implement CMIS. We didn't. We looked at XML and SOAP and thought, well, XML's actually got a lot of overhead with it. So we actually went down the path of JSON, and we'll even started on JSON LD, linked data, but we haven't had the time to properly implement all that yet. So what we've ended up with is a JSON API that is nice and lightweight. It can be easily used on mobile devices. Its structure looks close to MongoDB, as I mentioned before, and we can easily change our JSON API to be JSON linked data, so it has a lot more schema around it. It gives a DTD feel that you come to expect with XML or SOAP APIs. And that data can be used to really generate, pretty much generate all your content types across your network from one single content repository. In theory, anything could be dynamic. You create it in the content repository, and then it would just end up in Drupal. Let's say you had a cron job that checked the content repository and automatically created new content types. The idea is that we're just overflowing when it came to looking at JSON LD. But we haven't implemented it yet because we're taking baby steps. So our service looks pretty straightforward. We use the usual get, put, delete, post that you come to expect with a RESTful service. We have a document path. We also have a vocabulary and a term path, and we use UUIDs in our content repository. We use UUIDs because our content can be created on any Drupal site at any time. It's not created in the repository. It doesn't get created in Drupal, which then pings the repository for an ID. It just gets created in Drupal. At some point, it'll end up in the content repository. And I'll come a bit more about that process soon. Our JSON service is straightforward. It looks very familiar to what schema.org looks like. It's just we have extra fields like UUID and is published. Extra fields that just help out the content repository and the Drupal sites. Right, so the next big thing was dealing with how we push this content around our system. At this point, we'd conceptualized that we can create nodes in Drupal. We can, through a REST API, put content into our content repository. But what we hadn't worked out was how do we manage changes. Our end goal is to be able to have site A push content through to site B somehow. We didn't quite know how. So we came up with an idea for a messaging queue, which is quite straightforward, really. Messaging queues have been around for a little while. I like to think of this one as more of like a binary log. If you think about MySQL, we have a point in our messaging queue. Actually, I'll just skip through to this one, go back. So we have a stack of UUIDs in our messaging queue. Site A will have a pointer to one part in the queue, and site B will be another. And basically, they just process through this JSON feed constantly. We did look at things like pub, hub, sub. They kind of do this as well. But if your site goes offline, it misses notifications. We needed something that could be decoupled and modular. So in the event that site B goes offline and events keep getting added to this message queue, we needed a way for that site to catch up. So the messaging queue was crucial to the design of the content repository. And it has a basic concept around it of we have a UUID for the actual message. We have the source UUID that it's referring to. It could be a document, it could be a taxonomy term, it could be a vocabulary, it could be an image, it could be anything in the repository. We represent that by source type, a timestamp of when that message got created, not the document, but not the documents like create date or written date, publish date, but the event date. And we have an action. So this queue can have creates, updates, deletes. They pretty much translate to what the RESTful service does. And the only knowledge that our content repository has of all the other websites is this one field that says source site. It's the only knowledge. There's no knowledge in that application that, this is the IP address of this website. This is the database. This is how I should push through content to Drupal. It doesn't happen in that direction. Content doesn't get pushed from our Symfony service to Drupal because that's not decoupled enough. It requires more maintenance. If we brought another site on board, we've got to go back to the repository and make sure it's all working. It just added a lot more complexity and a lot more risk. We wanted something that could be written at the start of this project, the messaging queue, and then just left and it'll work. We can add sites on as we go. So the messaging queue, again, has a JSON API. It's just like the others. We call them events. And a basic, it's read-only. And we just say events since the UUID and give it a UUID. And we get 200 events back from then and we can process. We'll take the last event, we'll pass it back to the API, and we'll get the next 200 events if there's more to process. If we don't know a UUID, potential onboarding of a brand new website, well, we had to come up with a way to just say, well, give us events since this timestamp. It's relatively straightforward, that one. I'll come back a bit more to the messaging queue as I talk a bit further about how we integrated Drupal to the CR and the modules that we wrote for that. But I'll just go sideways into taxonomy. So taxonomy is a long-time strength of Drupal. It's really awesome. Not many content management systems have it quite down pat like Drupal does. So the CR naturally required a way to store terms and vocabularies in it. And what came up with this is that, let's say I tag an article on site A with I don't know, cheese. That's my tag on that article. And then I, at the same time, tag an article on site B with cheese. What we end up with is actually two individual terms that have had UUIDs generated in two separate Drupal installations because everything's detached. Let's say the queue hasn't processed yet, hasn't ended up in the CR. We end up with two UUIDs. So there's a bit of complexity in our system about synchronizing taxonomy terms between sites. And they're a little different to how articles work. But at the end of the day, taxonomy terms are unique by their name rather than their UUID. So that was an easy resolution to that one. We go site A. Okay, chicken instead of cheese. Must have been eating chicken at the time. So, site A, chicken, will push its term to the CR. CR will end up getting the term chicken and store it. At some point, whether it's in the next minute, 5 minutes, 2 days, whenever site B is online and ready to check the messaging queue, site B will pull the queue from the CR, process that list of messages, see that there's a term there that says create, or see that there's a message there that says create, and it's got a UUID. It'll go off and fetch that term, and then all of a sudden our chicken has ended up in site B. At that point, it's going to then do the synchronization of, oh, I already have a term called chicken. CR says it's this UUID, and I've already got this one. So I'm going to ignore the one I've got in my Drupal and just replace the UUID with the CR. The CR is treated as gold in terms of UUIDs. Even though it doesn't create them, it is the one true repository for UUIDs. And that was, I think, an important point in the design of when we were thinking these out. And it came to us not so quickly, surprisingly. So the next big thing around our content repository was search. At this point, we had a nice little API. We could push articles in, articles with taxonomy as well. And we're still doing things through mock-ups, not necessarily much Drupal integration at this point. So we're wondering, well, how do we find this content, and how will Drupal find it long term? So Mongo's okay for basic searches. It's got some nice free text or regular expression text matching. It's all right when it's on basic fields or array fields, keyword fields. But ultimately, we needed something a lot more stronger. So we ended up using Apache Solr with Symfony. I used Drupal Solr schema XML just because it's actually a really awesome schema XML. It has a lot of dynamic fields already defined in it and just saved me scanning the Solr documentation and building my own. Also used the Solarium library, which is totally different to what you'll find on the Drupal community of Apache Solr library or the Search API library. They're their own implementations. The Solarium library it's on GitHub. It's easy to obtain. I think it's the best Solr integration library I've ever used, having used both of the Drupal ones as well. It's much more heavily classed and can easily swap out different HTTP connectors as well. We ended up writing annotation drivers for this particular library for Symfony, for Doctrines specifically, so that in our class where we have an article being defined in Symfony, just below our Doctrine Mongo ODM annotation, we'll put the same kind of annotation for Solr, mapping that field in the class directly to either a dynamic field or a non-dynamic field in Solr. That made the mapping really, really easily. We knew what our content types were going to look like, and we just add like a dynamic string annotation on it, and it uses that field name, and by way of annotation drivers, it ends up in Solr. I'm really keen to contribute that back to the Symfony community and wondering if there's a way to get that into some more Drupal 8 contrib. So the CR indexing process itself actually subscribes to the event queue. And again, this is why the messaging queue or the event queue became so important in the design, is when it comes to processing batch jobs in the CR, it was perfect candidate. We have a full list of creates and updates of content of all these articles, and what better to get to subscribe to it than a search indexer. It made it very, very straightforward to just process a batch list of content to then throw it Solr, and all of a sudden it's indexed. Another benefit to using Apache Solr was that Drupal's integration with it is really great. There's a couple of modules on the community called Sarnia. Sarnia works with Search API, which works obviously with Drupal. Sarnia allows you to use a non-Drupal schema with Drupal and views, and just creates all those entity relationships for you. So that's allowed us to use a non-Drupal search engine, even though it's using the same schema, and easily provide the mappings through to our front end. So now moving on to Drupal, we've ended up with one main Drupal 7 install on our servers. We have one install profile, which we've called SBS distribution, and we have one main theme called global for all of our websites. As I mentioned before, our new design is much more standardized across our network. I have a screenshot of it at the end of the presentation for a bit of a sneak preview. And so what we've ended up with is sub-themes that more or less just replace some imagery and minor CSS colors and things like that as we roll out more sites across the network. And so what we've built into this global theme is full responsive system as well, to meet that one of those earlier goals where we wanted everything to work on a mobile or a desktop or a really massive desktop, etc. We've got multi-site installs happening as well, so some sites will naturally have their own modules. Not many so far, but if it comes to things like features, exports, definitely they can live in their own sites rather than living in the base distribution. Our food site has very different structure and listings of views compared to other sites. So that's just a little bit on our Drupal setup. But to get Drupal to connect to the CR, we needed three parts. We needed a Drupal module, or a couple of modules in fact. We needed a client API that is a bit more standardized, that can connect to the repository. And we needed our CR service. So we've got our CR service at this stage, and we have a client API in process. So the client API we ended up building out as a standalone API, a library that you can just drop in Drupal. And the reason for this was that we also have our legacy sites that still actually need to use this and put content into our repository. It also keeps things decoupled. We can upgrade things at different stages, and the functionality in some of the API seems to push the limits of what you would want to do in the structure of Drupal as well. It's more like a Symfony 8 structure rather than Symfony 7. It uses PSRO standards, which Drupal 7 does not, unless you use something like Xautoload to help you out there. So the API handles the conversion from basically the JSON that comes from the content repository, and it converts it into a strongly typed object that you can then hand off to Drupal. And so built into this API, this client API, this idea of field handlers and an object translator. It has some very similar concepts to what the Drupal migrate module does in itself. It needs a bit more work. I'd hoped that it would be able to connect to the Symfony service and get pretty much the schema from Symfony and generate a lot of these classes automatically and then push them through to Drupal. But again, it's just time is the only thing constraining us there. So at this stage, we had a client API that could connect to our Symfony service. It does a lot of the error handling, throws exceptions when there's problems communicating with the repository. This was a point that we had to really fine-tune and write a lot of unit tests around, because our content repository was going to be such a core part to our new network. It just has to work, and we couldn't have risk of just one little thing messing up everything, because all of a sudden we're going to have 60 sites that can't connect to our repository. So at this point though, it's still not connecting to Drupal. So we needed a bunch of Drupal modules. So we ended up with about 5 main modules. We have a server provider or an API wrapper. It imports the library, and it has some basic methods for pushing and pulling content to the repository. We actually call them push and pull in the system. We have an entity integration or a field module, and I'll show some screenshots of that shortly, actually in action. We have a module for an event queue processor. Drupal's queue is mostly good enough, but we've had to extend it to put a bit more data into it as well. So it's just class extensions and defining queues of how we want. So we have a queue that can push content, a queue that can pull content, a queue that can subscribe to content and then process things in Drupal later. It's just another queue module that has kind of been backported from Drupal 8. We also have modules that help us out with the Search API, Solar and Sarnia. We didn't write them, but we've had to do a fair few patches on some of them because they're pretty raw, they're pretty new in the community, they need a bit more work. But we've also contributed those patches back as well. And there's some custom code around facets as well when it comes to things like filtering on dates. When you use Search APIs, Sarnia, it's not as easy to map, I guess, content or the structure of a field into what it should render out in views. So it needs a bit more hand-holding. So our server provider module implements the push, pull, and delete methods. It's hooked up to parts of the entity API. It more or less just takes the entity object with a server wrapper, or entity wrapper, sorry, and pushes it through to the client API. It handles extra things like more error handling, takes the errors that come up from the client API, from the exceptions they get thrown, and puts them into Drupal's watchdog or any other logging system we're using, and provides a nice, easier way for using the entity metadata wrapper for setters and getters. So the next one was creating the field or the entity field module, which is probably the coolest part about the integration. It sits on every single content type we have. Taxonomy and vocabulary is inclusive. Images, file, we use file entity as well. It's just one little field that we call CR status. You can call it whatever you want. It has the ability to choose from a drop-down of the content source, so we can hypothetically have multiple content repositories. We don't, but we can. And our client API gives us a bit of schema around what content types are available or what collections. We've tried to use some common terminology to what gets stored in MongoDB as well. This is a field on a node when you're editing it in the administration section, and this mapping just appears. So I can be on a node of type article, and in here I can say, well, it's going to map through to article in the content repository. So we've tried to keep this fairly decoupled so that we can, in theory, map any content type to another content type in Drupal that doesn't have to adhere to strict mapping. On the left are the fields that come from the content repository. The middle column is the target fields in Drupal. And then on the right, we have this field handler interface that I mentioned before, where some fields can map directly one-to-one, like the type field in Drupal or is published. I mean, that's just an integer. There's no fancy arrays around that or language, multilingual metadata around it. But for other fields, we do need handlers. And so a lot of the fields use what we've created as a Drupal field handler, which just has all those cases around it. Is it an array? Do I have multiple elements? Am I multiple storage, or am I a single element? Do I have different languages inside me? That kind of thing. Some of the other fields need a bit more work around them. We've got some custom fields that we've created for our restaurant content type, which shows opening times and things like that. So that kind of data is stored a lot more generic in the content repository. But in Drupal, it's quite different because it's a custom field in Drupal. So we still wanted to be able to use the awesome power of Drupal and its fields, but we still wanted to keep the data tidy in the CR and not necessarily being inflicted by Drupal's structure. And this was the key part to keeping that separation. And so the server wrapper basically looks at this field whenever it gets to a node that needs to be pushed through to the repository and inspects each of these and works out what it should be mapping. It maps it to the strongly typed class in the client API and then pushes it through to the repository. It amazingly works really well. So the next big module in Drupal is our queue processor. I kind of already mentioned it. It exposes the update, create, and delete queues for our entities. It does use the native Drupal queue, but it extends it. There's a few extra fields that we've needed in our queue for things like debugging. If we end up with a site that has maybe 20,000 items that need to be pushed through to the repository and one of them is jammed in the queue, we needed a bit more insight in how to actually fix that issue. And the standard Drupal queue actually just stores all your data as blobs in a column and doesn't really give you much insight unless you load up the item and then inspect it. But that's annoying if you've got a lot of items in a queue. Our queue processor also subscribes to the event queue. So on cron job or on drush cron, whatever we want to run, it processes our event queue in the content repository and steps through and actually stores each item from the CR event queue in its own Drupal event queue, which it then enacts on. And part of this reason is, again, what if the CR goes down at some point, or what if there's a problem importing the content to Drupal? We needed a reference point where it would go, hey, this event had an issue. We're not going to run anymore, but here's the one that had the problem. Now we can go and inspect it. It's all about, if we have a problem, how can we quickly resolve it? Again, central part of our system. It's important that we had these worked out. So the queue manager at the moment is fairly straightforward, but it could have a lot more of an admin interface around it. It just has a nice straightforward, you can push a queue or process a queue, and it uses Drupal's batch API to just run through the items. It has a lot of logic tied in with the server wrapper on how it handles failed items. So when you push an article, potentially things like taxonomy terms haven't ended up in the CR yet. So it has to then find out dependencies, add them to the queue beforehand, and then process them. So there's some clever logic in the processor as well. And then I took a screenshot of it actually working, which we only got to this stage in the last couple of weeks in our build. We've started ingesting content from our legacy site into the new Drupal build. We're working on the food site at the moment, and we're testing out pushing all this content through to the repository, and I indexed 3,000 or 4,000 recipes in an afternoon, and it was just happily pushing the items through the queue. So it was a really good moment to see that happen. So I'll go over the big picture of how we connect to Drupal now. I've said a lot, it's probably quite confusing, but I'll just step through it. So we have a node, we save the node. The CR field takes a snapshot of this node in its current state and puts it in the Drupal queue. And that's all that happens at that point when the user's interacting with that node. We didn't want to push it directly through to the content repository at that time, because what if the repository is down? Or what if there are other problems? It would be blocking the user's work, and the site can continue working without it ending up in the repository. It might not be accessible on other websites yet, but at least the particular site that this content is on can still function properly. So then we have a divider, a time divider on cron. We push the queue in Drupal through the server wrapper, which then converts the node by referencing the CR field, does the mapping and the translating, and it pushes a strongly typed object that the client API likes and can validate through JSON curl to the CR service, which will then either persist it, which will come back with a response that's fail or success. If it fails, it'll end up back in the queue, and it'll either work the next time because it's solved some of its dependencies, or we'll have to go and inspect why it's failing. So it's all simple. I'm going to put it open to questions now, because there might be lots. There's a lot that I wanted to cover in this hour session, but at the end of the day, it's only an hour. So questions, please.
So just in that example there, you showed how you push an article to the CR.
Yep.
How do you get the article from the CR to another site?
Yep, okay. So I haven't really covered that because I knew I'd run out of time. Because views is integrated with our search, we have a page which allows the editor to just type in whatever the hell they want. They can click a button and it'll just have like the title of the article, for example. They can inspect it on the current site that it exists on because it's a link, and they can just hit import. And that doesn't get, no, it does get added to a queue. It gets added to a queue that is immediately run. And in event of failure, it stays in like an import queue so that we as a developer team can inspect why it wasn't working. But it's the same process, it's just reversed. So it goes from the CR as a GET request from that /document/UUID URL through the client API, converts it from the strongly typed object to a node through the server wrapper, and that commits it as a node through the entity metadata wrapper.
So is it pull or push?
It's
like the other side, just pulling?
Drupal's pulling and Drupal's pushing. So pulling is grabbing stuff out of the CR and pushing is pushing it into the CR.
So just some cron,
Yeah. Yep.
So in effect, are you actually creating a copy of that node that lives in that Drupal instance
Yes.
with reference to the global?
Yep, absolutely. We had a number of criteria set out to us from our editors, which gave us scenarios of they would create content on one site and want to use it on another site, but they would say that, but then they might also want to change that content and not necessarily have a direct clone. So we came up with a few methods of, we can import the content, the CR field keeps track of its source, so we can deal with canonical URLs quite well and not get taxed for SEO. And if the editor wants, they can detach it from the CR. The relationship's still there, so we know that it's still got a loose connection, but is its own entity in that point. And at that point, the CR field will then actually start to push that new content into the CR as whole brand new content. Up the back there.
Yeah, awesome presentation, really cool system.
Thanks.
So I guess these really nice, clean solutions, from a developer architectural perspective, usually get derailed by business people and their, stupid ideas. Like, did you have any of that in this project, or like, how do you deal with it?
Do you want to speak on that, Matt? Put you on the spot. So Matt Castane's the technical director at SBS, so he's my boss.
We have heavily pushed back on the business and said we need to get this right before the rest of the networks work. And they've been very supportive. They haven't necessarily seen the fruits of the labour yet, but when we do show them what we've done, they're kind of like, okay, this is starting to make sense. So we've actually pushed back a site launch, the food site, from late last year to February to sometime in April, just to make sure that we don't have the business derailed.
Just curious about how you give your content authors visibility of what's changed, assuming the system is all working, then updates on some other part of the network will update some other site.
Yep.
Presumably people want to be aware of what has changed.
Yep, good question. So the question was, how do we manage updates on other sites and let editors know? Our CR field has a plugin system that we've written into it, and it allows us to just write any plugin from send an email. As Drupal processes that event queue, it'll see that it has that UUID in its system, and it goes, hey, I've already got this article as I'm processing this queue. Do I need to do anything on it? It sends it to this plugin system, which will potentially send an email to the editor saying, this article's been updated, do you want to change it? Or it's been updated at its source, sorry. And then the editor can go, oh, mine needs updating now, or it can be automatically updated. They can tick that box as a plugin, or they might not even care at all. So we've kind of captured those as well.
So that answers a little bit what I'm thinking, but I'm just wondering about the pre-publication part of this. So you've got content authors and editors.
Yep.
In a media organisation. Are you using Workbench? Are you using something else? What sort of editorial modules are you using?
Believe it or not, we haven't actually started working out much of our editorial workflow. Our workflow varies from department to department, but it's fairly lightweight. Regardless of the workflow, though, it won't get pushed to the CR until it's ready for publishing or finalized. Or when we get to actually building that in, that's probably what will happen. Yep.
First and foremost, this looks pretty awesome, just straight off the bat. Just kind of couple my next comment. Was there a reason you guys didn't look at doing something like domain access with shared tables or database sharding?
Domain access in terms of Drupal?
Yeah, essentially.
Horribly messy when you go down that path, in my experience. Didn't feel enough decoupled, decentralized, and wouldn't have given us enough flexibility around our APIs of what we want to do long term. Having our repository as an API just opens up so many doors of how we deal with content on mobile applications as well.
So a key part here of your architecture is this messaging system where you can push and pull nodes from one site to another.
Yep.
Which you can do without the CR, right? Like you could take a node from one site, push it straight to the queue, and have another site pick it up if you're using something like RabbitMQ. So,
yep.
And of course, you're using the exact same code base for every website, so they could all theoretically store all content types and features.
Yep.
And you can use Apache Solver multi-site to search the entire or everything across all the sites to find all the articles.
Yep.
So my question is,
why didn't we do that?
yeah, why? Because the CR, I mean, it's kind of nice and enterprisey and very fully thought out, but there is also that option there, which means you wouldn't have to build
So
an API.
it comes back to the point of being decoupled. Our CR benefits from not knowing about any other Drupal website. Our Drupal websites don't know about the other Drupal websites at all. They just know they can get content from somewhere, they can import it, and they can react on it if there's an update to it. And the point of it being decoupled is that potentially our food site could, maybe it'll get sold off to someone else, or maybe SBS will merge with ABC or Channel 10. Who knows, But we wanted to keep it.
There's another point. Like our CR isn't just for the Drupal sites. We've got a big plan. It's going to be like a service for like the whole of SBS. So potentially in the future, other departments might want to have access to it as well. So it's
And beyond that, we want to open it up externally, so like much in the way that Guardian have done an open data project in the Netherlands, so that public can play with it.
In red?
Yeah, really awesome. Just curious how big the development team is and how long it's been from sort of scoping to sort of getting to this stage.
Building the CR itself probably took Ari and myself a good 4 months. So that's 2 devs, 3 or 4 months. We had a little bit of time before that where we were conceptualizing it with a greater team. In terms of the Drupal implementation, we've had some assistance there from previous Next, just as Drupal resources. And now it's all in-house. Our in-house dev team is actually around, 12 people? Yeah.
And are they all Drupal people or PHP people?
They're all Drupal people. They're all Drupal people now.
Right.
Yep.
Do you have any concerns with MongoDB being falling over, losing data? I guess I've heard it's one of the things, but I heard stability is always a concern.
Not yet, and we haven't seen any issues with the stability yet. We've got a good relationship with Tengen here in Sydney now as well. So if we do run into any of those problems, we can ask them at that point. But MongoDB, whichever version it's at, 2.2, 2.1, 2.1 point something, it's fairly stable now with all of its replication. It had some bugs in the drivers of PHP connecting to MongoDB, which caused some issues with replication. It had rapid development in the whole replication area where it took a master-slave method, I think back in version 1.6, but now it's a lot cooler with the primary and secondary and failover, and you can set up off-site backups that can be invisible nodes but come online if they need to be, so that's great for redundancy as well.
Just a bit further than that, because the sites and Mongo are decoupled, if Mongo disappears, the sites will function perfectly.
Yep.
The editorial process doesn't stop, the editors continue to publish content, the sites get updated. It's just the content doesn't become available to the other sites until Mongo comes back.
So maybe one day if we didn't want to use Drupal anymore, that would be pretty easy as well. We'll be able to build up a new site in non-Drupal. Yeah. Yep.
Just one more time about how the CRQ knows to which sites the whole thing was pushed.
The
You stored some kind of identifier. Yes, it wasn't the beginning.
The CRQ doesn't really know much about.
So if you create a new site, how the queue would know that it has to?
Doesn't. It gets one text word in there. Sorry, I'm just trying to find it.
Or the site which is pulling would know.
Yeah. So every site has a unique ID of.
every site has a pointer
Yeah.
to its last page.
Every site has a unique ID of its site, and it'll look in the queue of is this my content or is this another site? So that allows us to index it per site as well, so we can actually see what site it comes from without applying specific domains, URLs, etc. Yep. I would love to open source this stuff. It's not quite ready for that. The Symfony stuff potentially is. The Drupal stuff not quite, because we need to do a lot more testing. But anyone who wants to help contribute to this or wants to be using it themselves, definitely get into contact with us at SBS. Very keen to contribute back to the community.
Yeah, part of our adoption of Drupal, one of the sort of softer factors was the Drupal community. So we fully intend to commit anything that's not commercially sensitive back into it. And we see the CR as something that would be very useful for many organizations, so there's no reason not to put it back.
So what about CRQ and the CR itself?
It's all part of it, yeah. We'd want to contribute that back. Yep.
It might sound like a dumb question, but you've got the content repository, which is like your master database.
Yep.
Do each of your Drupal sites have their own regular Drupal database?
Yep. Yep. It's just like a standard Drupal install. They have their own content types. Just build it out like a normal Drupal site. And then through that field mapping, that's where the connection happens of where content gets mapped through to Drupal. Yep.
What are you using to search on the front end?
Search on the front end is GSA. We have a Google search appliance that crawls our network for the majority of our network, but on things like our views are backed by Solr, and it's the same Solr index that the content repository is using. So the Drupal is using Search API with the Sania plugin to read the index, never does any writing. The CR itself does the writing to the search index.
So is that for choosing nodes to import into
Yep.
the site?
Yeah, well, not just choosing for an editor, but even displaying. Let's say this is content. This potential content could come straight from the search index and be represented on the page.
Related more like this kind of box, that's what
Yeah, eventually anything you'd normally get with a Solr implementation is what we can do now.
One more question about assets, like files.
Yep.
Media, what is it stored? How does it get distributed?
Images are stored in the repository. We built an image API path as well. Goes in as a JSON object. We use file entity in Drupal. And on push, it actually base64 encodes the image, which then gets decoded. And that was the easiest way to push the metadata around the image and the image itself. So if any of you went to the services thing this morning next door, and they were talking about how we're going to get services working with Drupal 8, I think that's the solution, is just to use something like base64 to push and put and get your items out. We still actually have an actual path where you can browse the image as well, not just pull it out through JSON that's encoded.
But what about other documents, like whatever, Word documents, whatever they get?
Files. We haven't built files in yet, but it'll be the same code. It's the exact same code in our repository.
So everything's going to be stored in CR and then just pushed.
Anything that's attached to a node of a file entity can be pushed through to the CR. We do have CDNs at SBS, yeah. Any more questions? Awesome, that's 6 o'clock. Thanks for coming.